Lewis here. Welcome to your next module. We're going to be dealing with trigonometry. I know a lot of you have been freaking out about trigonometry and what we're going to be doing with it and everything like that. But I can go ahead and tell you it's not as bad. Again, you hear me say this all the time. It's not as bad as you think. Alright? So chill, relax. We're at home. Listen to the birds chirping in the background and the cars going by, and just smell the fresh cut grass and relax. It's cool. Alright, so let's just kind of go over where trigonometry kind of comes from. I'm not going to go over so-and-so made blah, 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 blah. I'm not going to do any of that. Just want you to understand some basics. So I have a very simple Cartesian plane in front of me. I don't even have anything labeled down here because right now it doesn't matter. Same thing with my y-axis. Nothing's labeled. Alright, so on my Cartesian plane I'm going to draw a point, and let's just say it's right here. Okay? So I have a point. My job now is to create a line that goes from, or through rather, this point all the way to our origin point, which happens to be, as you should know from grade school again, R00. So that's what I'm going to do. Alright, there we go. Not very good, but good enough for our purposes. Alright, so now we've got this thing going on here. What we've discovered is a couple things. First off, this point has two things. It has an x value and a y value. So we know that it has an x and we know it has a y. Alright? The other thing that we know is that we can start comprehending how far did this period move. If it started here, how far this direction it went, and then how far this direction it went. So let's kind of do that right now. So we know that it went from here all the way to approximately here. Okay? So this amount of space that we've done, we've moved from the origin point over here, is approximately x. We don't know what it is. Could be 4, could be 5, could be 3,000 for all we know, but it's x. The next thing we need to understand is how far up it went. So it probably went from, I'd say, about here all the way to here, and it went y space. Might not be able to see that too good. So it went y space. Again, same thing. We don't know exactly. It could have been 2, could have been 3, could have been 5 million for all we know. But it went y. Alright, so we've got that little bit of information. Well, there's some other things that we can kind of notice about this. And let's say, for instance, if we drew a vertical line, went straight down from our point. Alright, so we have a vertical line that we have drawn straight down from our point that we have. We notice that this vertical line makes a perfect 90-degree angle with our x-axis. So what do we see? Well, we have a line here, we have a line here, and then the x-axis, and what we actually see is basically a triangle. So if we know the x and we know the y, and we know that this is not just any type of triangle, it's what we call a right triangle, we can actually find the distance between here and here. Well, how do we do that? Well, think back to geometry, excuse me. If we're going to have a right angle triangle, how do we find the hypotenuse? Ring a bell? That's really what this is. Well, we use Pythagorean theorem. I'm not going to write all that out. I'll say it, a squared plus b squared equals c squared, and we would find out that this guy would be technically our hypotenuse. Alright? However, when we're working with trigonometry, we don't label the hypotenuse on this one as c, we label it as r. So what we actually find out is this: r squared is equal to x squared plus y squared. So if you know your x value, notice how I've given you a point here, which is x and y. If you know the x and you know the y, you can just basically plug it in Pythagorean theorem and you get r squared equals x squared plus y. So no matter what I give you, you can always find the other side. Now, that's the basic concept of things. It's basically using Pythagorean theorem to kind of describe all this. However, there's some combinations of things we do more in trigonometry. We start comparing the different sides to one another, and we compare the sides to the angles that they're attached to, and through a bunch of magic we end up coming up with trigonometry functions. So this is what we're going to do. I am not writing all the trigonometry functions on the board because, one, I'm lazy, and two, there's not enough room. What you need to do right now is, if you haven't done it yet, is to print out the formula sheet. We're going to be using that a lot through the rest of this module. Now that you've printed off your formula sheets, I really want to go over how these are pronounced. The formula sheets don't really tell you that. So the very first one that you see is S-I-N, and then it's a little circle with like a Superman haircut with a little, okay? What we really do is pronounce this sine of theta. So in your notes, make sure you write that down. It is pronounced sine of theta, all right? The next one that you see is cosine of theta. So it's not just cos, it's cosine of theta. The next one is tangent of theta, followed by cotangent of theta. And then we have the next one. This one's a little bit different. It can be pronounced two ways, either secant or secant. I guess it's basically whether you grow up in the South or not. I'm not really sure. But I was told it was pronounced secant. So you'll hear me say secant a lot. If you pronounce it as secant, from what I can gather, it's about the same thing. All right, Google it. Okay. The next one is cosecant. Actually, from what I can gather, that is the proper way of pronouncing that. I don't think it's cosecant. I think it's just cosecant. So we have sine, cosine, tangent, cotangent, secant or secant, and then lastly cosecant. And that value with the 0 is always called theta. All right, and that generally represents the angle that we're working with. So what I'm going to do is, instead of trying to give you all these different definitions of the different trigonometric functions, I'm tired of saying trigonometric. I'm going to just start saying trig functions. It's just a whole lot easier, and with my thick tongue, we're just going to say trig. All right, so all these trig functions, instead of detailing each and every one of these things, it's a whole lot easier just to give you a problem and show you how to work it, and basically throw you to the wolves, and you'll learn how to do it yourself, and actually you'll figure out that, hey, this is pretty easy. All you got to do is know this, that, you're done. All right, so let's just go to it. This very first problem I ask you to do is to find all the different trig functions that go through the points 6 and 8. So I have a Cartesian plane here. I'm going to find 6 and 8. So we know how to do this. Here's my 6. We're going to go up to 8 and try to get this right. We have it right about here. So we have our point at 6 and 8. Our job is to find all the different trig functions. Okay, so how do we do that? Actually, really, we don't even need a Cartesian plane to do this, but I want to show you how to do it with a Cartesian plane first, and then we'll start doing it without, just so you can see what's happening. All right, so we have our point 6, 8, and what we want to do is basically kind of draw a line through it. All right, so that's what we're going to do. We're going to draw a line through it right here. And the next thing that we want to do is kind of understand that this point is going to end up, we're going to end up making a right triangle here. So I'm going to draw a vertical dotted line right here going from our point down to the x-axis. Alright, so that's what we have going on here. Now, what can we find out just by looking at this? Well, first off, we know that our point happens to be 6 and 8. So what are our side lengths? I got breakfast coming, so I'm going to eat while I'm talking. All right, thank you. So, I have breakfast. It is eggs and bacon. All right. Wakey, wakey, eggs and bacon. Oh, no, it's not bacon. Sorry, toast. All right. So, we found out a couple of things just here. We know that our point is 6 and 8. So, how high did I go up? Well, my height from here to here, well, is 6. Well, isn't that a coinky-dink? No, not 6. 8. Isn't that a coinky-dink? 8, the height of the triangle, is the value of the y. Well, how far did I go over? 6. So, this is 6. Well, isn't that a coinky-dink? It's the same thing as our x value. So, the height of the triangle, the length of the triangle, those are my two legs, happen to be 6 and 8, which are corresponding to my 2 points. So the job that we have to do first, before we can find any of the actual trig functions, is to label these two and then find out what r is. Okay, so how do we find r? Well, since this is a right triangle, we use Pythagorean theorem. And we know this, that r squared is equal to r 6 squared plus 8 squared equals, well, there we go. All right, so let's solve for this. And we're going to actually get a handy dandy calculator because I feel lazy this morning. So we know that this is going to be r squared is equal to 36 plus 64. Actually, I don't need a calculator. All right, so 36 plus 64 equals what? 100. So r, in this case, is just going to be 10. All right, so I'm going to label that over here. So I now know all the sides of the triangle that I have just created. I have 6, 8, and 10. So what we need to make sure is that we know that this is our r value. We know that this is our y value. And we know that this is our x value. So we don't need to forget that. Don't get confused. Just because you've got the numbers right, you need to make sure you know what the numbers are. R is 10, 8 is y, and 6 is x. Alright, so now we can actually start doing some things. So, what we're going to do is I'm going to erase this board right here. And what we've got to find out is all the different trig functions. So, first off, let's start off with sine. Sine of Superman circle head, alright, or theta. Alright, it says y over r. Okay, that's the first part. So if we want to find sine of theta, we just simply put y over r. In this case, our y is 8, our r is 10. We can reduce this, so since this is a fraction, we can reduce it to 4/5. So our sine of theta is 4/5. Now we're going to keep on trucking. Let's go on to our next one, which happens to be cosine of theta. Well, cosine of theta is x over r. So x over r, our x is 6, our r is 10. This can be reduced. We can say that this is 3/5. Okay? So cosine of theta is 3/5. Let's do the next one. Tan of theta, or tangent of theta. Okay? Well, our tan of theta is going to be y over x. That's going to be 8. Our x is going to be 6. We can reduce this. Well, we can say this is to be 4/3. Okay? So, our tan of theta is 4/3. The next one is cosecant of theta. Well, according to this, cosecant is r over y, so it's going to be 10/8. Well, that can be reduced to 5/4. Next one that we have is secant of theta. Well, secant of theta is r over x, and r happens to be our 10. Our x is 6. This could become 5 over 3, or 5/3. The last one that we have is cotangent of theta. And we find out that it's x over y, so we can say 6 over 8. Well, that's going to go down to 3 over 4, or 3/4. Alright, it's just that easy. Once you know your x, your y, and your r values, you just basically plug it in. You know sine happens to be y over r, plug in the numbers, simplify, and you're done. Okay? So what I want you to do now is I actually want you to try the next problem on your own. It's asking you to go through the point 24 and 10. Alright, so we'll discuss it in a few minutes, so pause the video, go over it, and try it on your own and check your answers. Just know you don't have to do what I did. You don't have to draw this. Okay, it's not necessary. You can if you want. So when we go back, I'm just going to go right through it really fast. I'm not even going to use this. So if you don't want to, you don't have to graph it. You could go right straight to the numbers and be done. Alright, so just be aware of that. So pause the video, take a few minutes to do the next problem, and come on back and we'll discuss it. Alright, so in this problem, when you were asked to find the trig functions that go through 24 and 10. Alright, so what you know right off the bat before you're doing anything is that your x value is automatically 24, and you know that your y value is automatically 10. You should know that like that. Now, your job first, before you even start worrying about sine, cosine, and all these wonderful things, is to discover what the r value is. Basically find out what the hypotenuse is, or the distance from the origin point to your actual point. Okay, that's really what you're doing. So, Pythagorean theorem, work it out. You should have got r is equal to 26. So now you know your 3 points, your three measurements, excuse me. You know x is 24, you know your length of y is 10, and your r is going to be 26. From there, it's simply just plugging things in. Y of theta is actually equal to y over r. Plug in the numbers and you get 5 over 13. Cosine is x over r. Plug in the numbers, reduce, you get 12 over 13. Tan of theta, plug in the numbers for y over x and you get 5/12. Cotangent of theta is equal to x over y. Plug in the numbers, reduce, 12 over 5. Secant of theta is r over x. Plug in your numbers, reduce, you should get 13 over 12. Cosecant of theta is r over y. Plug in your numbers, reduce, you should get 13 over 5. Alright, so this next problem is pretty much more of the same, except I want you to look at what the instructions tell you. I won't actually read these off the paper. It says, do not round until the final answer, then round to 3 decimal places as needed. Now that doesn't sound like that all big of a deal. However, when it says do not round, it means do not round. A lot of times people read that like, oh, I can round to maybe 4, 5, 6 decimal places and I'll be okay. No. Let me say that again. No. It means do not round. So what we're going to do is when we start getting some, you're going to get a really funky looking number here in a few minutes, and you need to know what to do with it and how to put it in your calculator and keep it there. So what I'm actually going to do is I'm going to show you some calculator tricks right now to help you with this problem. So we're going to cut to the dot cam and I'm going to show you how to use your calculator. Alright, so in this problem we have we have 37.12 and 23.05 are x and y values. So that's what we're going to do. We're going to use this and we need to calculate our r values. So let's go ahead and do that. We know that r squared is equal to 37.12 squared plus 23.05 squared, and ultimately what we're going to end up doing is we're going to say that r is equal to the square root of 37.12 squared plus 23.05 squared. Now, I told you that you are not to round until the final answer. So how do we go about doing that? Because this is going to give us some weird little number. Well, let's just go ahead and find out what r is anyway. So we're going to hit the second square root All right, and then we're going to plug everything in. We're going to say 37.12 square plus 23.05 square. And then we're going to close that all the way in. We solve and we find out that R is this really weird number, 43.69435776. All right, now I want you at the very end to round, but I've told you not to round at all. So how do we use this information right here on a constant basis? Well, there's this neat little button. It's called, I like calling it the stow button, but it's really a store button. I just like saying stow because it's fun. And we're going to stow it. We're going to take this number and stow it. So what you do is you press this button, S-T-O, and it's got a little arrow. So you press that button now. All right, so your calculator should say this, arrow, and it has an X. Well, it says answer, and then it has a arrow, excuse me. All right, now what you're actually going to do is if you go right here where there's an alpha button, look right beside it, and it says X, T, theta, and N. All right, what I want you to do is I want you to press that button, and now it should say A and S, arrow X. Now what's happening in the calculator is this. The last answer you just got, which is this long 43 point something, is getting ready to be stored in your calculator as the variable X. So once you do that, hit enter. Alright, so your calculator knows that every time you hit the button X, it's meaning that it's saying, hey, I need to use this long-tailed number, 43 point something. So let me give an example. So we're going to clear out everything so our screen is blank. I'm going to say 2 plus X is equal to, well, there you go, 45.69. Well, wait a minute, I forgot what X was. Well, let's just say X. Well, X is equal to 43.69. So this is a very useful situation when you have to use numbers and you can't round until the end. Store it as X. Hit the store button and then hit X. Alright, so let's go ahead and start working with the problems. Alright, so what did we discover a while ago? We know that X happens to be the 37.12. We know that Y is 23.05. And we know that our R, well, it's like 43.69 something something something, and we've got that stored in a calculator. So now that we know all that, we can actually start working on the rest of this stuff. Alright, so let's go through each individual one real quick, and I'm just going to show you how to do one, and then I'm going to let you do the rest of them. So it says sine. Well, we know that sine of theta is equal to Y over R, which happens to be 23.05 over that 43.69 blah 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 blah. So let's just put that in our calculator. We're going to say 23.05 and we're going to hit divide by, and we're just going to hit the X button because X is stored as the 43.69. Hit enter and we get our answer. And now we can round to 3 decimal places. We're going to say 0.52, and now this 5 is telling that 7 to go up, and so our final answer is 0.528. So that's really what I wanted to show you, is that store button. When you get these really long decimals and you just don't want to have to remember them, store it. Alright, so why don't you go ahead and finish out the rest of these for me, and come back and check your answers. Alright, what you should have got was that cosine of theta is 0.850, tan of theta is 0.621, cotan of theta is 1.610, secant of theta is 1.177, cosecant of theta is 1.896. Just be careful if your stuff's close to this but a little off, go back and check it and check your rounding. That might be what happened. Maybe you just did some bad rounding. Alright, let's move on. Alright, so this problem we're basically doing the same thing. We need to find all the trig functions that go through the point -2 and negative square root of 2. Alright, so in order to do that, we should automatically know that our x and our y values happen to be -2 and negative square root of 2. Alright, so knowing this, we automatically should be saying, hey, what's our r value? So using Pythagorean theorem again, we go Pythagoras theorem, we go r squared is equal to the -2 squared plus negative square root of 2, all of that squared. Alright, solve for all of this, and we get r squared is equal to 4 plus 2, because -2 squared is 4, and the negative square root of 2 squared is 2, and we get r is equal to the square root of 6. Now, what I want you to do now is pause the video, and I want you to find all the different trig functions, okay? And when you get done, come back and let's talk about it. So once you've discovered, after you found out that x is -2 and all this right here, and you've plugged it into all your functions, is that you've got all these different things. And more than likely, this is what you've got for your answers. That sine of theta is the negative square root of 2 divided by square root of 6. Cosine of theta is the -2 over the square root of 6. Tangent of theta is the square root of 2 divided by 2. Cotangent is 2 divided by the square root of 2. Secant is the negative square root of 6 divided by 2. And cosecant is the negative square root of 6 over the square root of 2. Now, if these are what you've got, just like I have, we're only partially correct. I actually threw you a trick question in this one. The procedure remains the same, just like what we did, but some of these problems that we have behind us, or answers technically, have to be simplified. So let me explain to you. I want you to look back at your notes, and this is what it actually says. It says, simplify your answer, write an exact answer using radicals as needed. Use integers or fractions for any numbers in the expression. Now, what it doesn't tell you is this, is that what we have to do is called rationalize the denominator. Alright, rationalize the denominator. What does that mean? I want you to think of it like this. When we have a radical, such as the one cotangent, oops, on the other side, such as this one right here, it says, whoops, this is weird doing it backwards there. So we have yeah, here we go. We have cotangent, this is fun. Cotangent of theta is equal to 2 over the square root of 2. Now that square root of 2 that we have right here, we don't like it in the denominator. So what that basically means is every time we have a radical sign in the denominator, we've got to get rid of it. And how do we get rid of it? So this is kind of a basic thing of algebra, and I'll try to explain it to the best of my ability, is when we have an expression such as this, or an equation, or anything like that, and we want to change it, we can do one or two things. One, we can add or subtract 0 to that equation, okay, and in some sort of form. And two, we can multiply the equation by 1. Well, you got to remember something. 1 can be written in many different ways. I don't just say 1. I can write it as a fraction, 1 over 1. I could also write it as 3 over 3, or 1 million over 1 million. And really, I'm using different numbers, but the point is, I'm still using the number 1. So I need to rationalize this denominator by multiplying by 1. So what does that really mean? I am actually going to try to get rid of this guy by multiplying by this fraction. I'm going to multiply it by the square root of 2 over the square root of 2. Technically, this is 1. But what I'm really doing is I'm getting rid of this denominator here by multiplying it by itself. But in order for me to do that, I have to also have the numerator here. So what happens here is when we multiply this out, we know that 2 times the square root of 2 is equal to, well, 2 times the square root of 2. That's easy enough. And then if we multiply the square root of 2 times the square root of 2, we get just 2. So now we've got something here. We can actually take it a little bit farther. What do we notice going on? Well, we have a 2 being divided by 2, so we can actually just divide this. These things cancel out. And we find out that it's the square root of 2. So technically, our real answer for cotangent of theta is the square root of 2. Alright? So here's the ones that we need to kind of go over. What ones need to be changed? We've already talked about cotangent, so let's look at the other one. This one has a radical in its denominator, so we have to change sign. Looking at this one, we need to work on cosine. Tangent, it says the square root of 2 over 2. Do we need to do anything with it? No, we don't, because the denominator doesn't have a radical sign in it. So we can leave that answer just like it is. Secant, well, same situation. The denominator is a whole number. It is not a radical, so we don't have to work with that one. Cosecant, since this one does have a radical, we need to work on this one. So, what I want you to do is we're going to pause the video, I'm going to erase the board, and I'm going to pull just these three up. So, just to kind of remember, as of right now, your answer for tangent is square root of 2 over 2. Your answer for cotangent is going to be just square root of 2. And your answer for secant is the negative square root of 6 over 2. And what we've got to do now in the next part of the video is simplify the remaining three. Alright, so in the last clip we already solved for most of these, and now we just got to figure out what's happening with these three, because I told you we don't like radicals in our denominator. So what do? Technically we're going to multiply each one of these by 1, and in order to do so we're going to multiply it really basically like the denominator over itself, okay? So for this first one, we're going to multiply this whole thing by the square root of 6 over the square root of 6. In doing so, we're going to get negative square root of 2 times the square root of 6 is going to give me square root of 12 over, well, the square root of 6 times itself is going to give me just the number 6. Alright, so this may be where you probably have stopped at, but we can actually go a little bit farther. Go back all the way to Module 1. And just where we were dealing with square roots, we can actually factor out this square root and make it even simpler. So think about it. When I say, remember when I was talking about factoring square roots, we are going to try to find the largest perfect square that we can factor out of 12. Well, 1's a perfect square. What's the next one? It's going to be 4. Alright? Well, can 4 factor out of 12? Yes, it can. Well, what's after 4? The next perfect square is 9. Won't work. So we find out that this is actually equal to the square root of 4 times 3. This look familiar? We'll put this over 6. When we do, we actually get 2 times the square root of 3 over 6. So right now we have negative 2 times the square root of 3 over 6. Can we do anything else with it? Well, look, what do we have here? We actually have a fraction, negative 2 over 6. Can that be simplified? Yes, it can. It could actually be simplified to 1 over 3. So my final answer, technically for this, I'm running out of room, so sorry about having to write off erase, is the square root of 3 divided by 3, and that's all negative. So let's go through it one more time. We had to rationalize the denominator by multiplying by the number 1. In this case, it's the square root of 6 over 6. When we do, we get negative square root of 12 over 6. We can factor out a 4. So this, when we did, it gave us 2 times the square root of 3 over 6. And when we simplify it any farther, we get negative square root of 3 over 3. Alright, so let's try this next one. We're going to multiply by 1 again. In this case, since we're trying to get rid of the square root of 6, it's going to be negative square root of 6 over the negative square root of 6. When I do, I'm going to get, oops, that should be multiplied, not equals. When I do, I'm going to get a negative 2 times the square root of 6 over 6. Alright, now, this looks like a fraction, 2 over 6 again. So can we simplify it? Yes, we can. And we actually get negative square root of 6 over 3. So, let's try the next one. This one right here, we have to multiply by 1, and in order to do so, and to get rid of this denominator, our 1 is going to be square root of 2 divided by the square root of 2. Alright, when we do, we're going to multiply this out. We're going to get negative square root of 12 divided by 2. We can factor out some more here, and we get negative 2 times the square root of 3 over 2. Our 2's cancel out, and we just get negative square root of 3. Alright, so sine of theta is actually negative square root of 3 over 3. Cosine of theta is equal to the negative square root of 6 over 3. And cosecant of theta is actually just the negative square root of 3. So when you go to do these things, you're going to do everything like normal. It's just be very cautious. Make sure that once you find your x and your r values and you're plugging it in, that your final answer does not have that radical sign in the denominator. And in order to do that, you basically are going to multiply it by the number 1, which is whatever that denominator is, and you're just going to say that's denominator divided by itself. That's how we're going to set up the number 1. And we work it all the way out. It gets a little bit tedious. Take your time on it, just like everything. So if you have questions on this, I know this part gets a little bit more confusing on the trigonometry side, because it gets into it actually is using algebra now. And so just be aware of that. Take your time. And remember, we just don't like radicals in our denominators. Alright, so in this next problem in your notes, I give you the cosine of theta is 7 over 15. And I'm asking you to use this information to find out what the sine of theta and what the cotangent of theta is. Alright, so this seems more difficult than you at first, but the procedure is very similar to what we've done. Everything up until this point, I've been giving you the x and I've been giving you the y. Your job was to solve for r. Okay, this time I'm giving you something here, you just don't realize it yet. So first off, what is cosine? Well, according to our handy dandy, I'm going to put in here, according to the handy dandy formula sheet, cosine is x over r. There it is, x over r. So what did we just discover? Wait a minute. We got a fraction here, just like x over r. So we just discovered that x is equal to 7 and r is equal to 15. Well, everything else up until this point, I've been giving you x and I've been giving you y. This time, I've given you x and r. So our job, before we can even do this guy, is to find out what y is. So let's do it. We know that r squared is equal to x squared plus y squared. Basically our Pythagorean theorem that we gave you to at the beginning of the semester and the beginning again of this video. Plug in your numbers. This happens to be 15 squared is equal to 7 squared plus y squared. So let's go ahead and solve all this stuff out. We know that if we go ahead and do this, 15 squared, we'll go ahead and do it the long, easy way, minus 7 squared, we're going to work all this out, and we find out this is 176 equals y squared. Alright, now we got the square rooted. We find out that a negative square root of 176 equals y. And for the sake of time, what I'm going to actually do is we're going to factor this out and simplify it and break it down. So what is the greatest perfect square that I can factor out? So we can go through a bunch of things, but I think, if I'm not mistaken, it might be 16. So let's find out. 176 divided by 16. Yes, we actually find out that this is 16 times 11 is equal to y. We can factor this out to say 4 times the square root of 11 equals y. So that is what we just discovered. Our x is 7, our r is 15, and our y is 4 times the square root of 11. Alright, now, our job is to find out what the sine and cotangent are. So I'm going to erase all this in case we need some extra room to work. Alright, so, according to the handy dandy formula sheet, it says that sine is equal to y over r. So y happens to be 4 times the square root of 11, and it says r, so that is going to be 15. Now I have 4 times 11, square root of 11 over 15. Can I simplify this any farther? No, this is as far as it's going to go. There's nothing else I can do with this guy. Alright, so cotangent, according to, we have x over y. So our x is going to be, x over y is going to be 7, and our y is 4 times the square root of 11. Alright, so we don't like square roots in our denominator, just like we talked about last time. So I've got to get rid of that square root of 11. So in order to do so, I have to multiply by a 1, and in order to create that 1, I'm going to actually be multiplying everything by the square root of 11 over the square root of 11. When I do, 7 times the square root of 11, 711, welcome to 711, is 7 times the square root of 11 over 4 times, well, square root of 11 times the square root of 11 is 11. So now we have 7 times the square root of 11 over 44. Well, can we simplify this anymore? I don't know. We can always check it, but I don't think we can. Just double check. 4 divided by, excuse me, I'm pretty sure I know we can't, but I'm going to double check. Nope, we can't simplify it anymore. This is as far as we can take it. So, our sine of theta is 4 times the square root of 11 over 15. Our cotangent is ultimately 7 times the square root of 11 over 44. What you're getting ready to do for me now is to do the next 2 problems on your own. The second one is slightly different than what we've covered before, so I'm going to give you a slight hint on how to solve it. Basically, your first job is you find your x, your r, and your y values, and you do all that. But let's say you have something that says sine of, and then it's got second, and then that. Alright, so you have this part of your equation. What this is actually saying is this. Whatever the sine of theta, you're going to square it. So let's just say, for the sake of argument, that after you've done all your work and you find out that the sine of theta is actually equal to, I don't know, 1/4. I'll be amazed. That's just a guess. I hadn't even worked the problem, so if that's the answer, I'm sorry. So let's just say that the sine of theta happened to be 1/4. You're actually going to plug in 1/4 into this. So you're going to say 1/4 square. When you do, solve it like you normally would. That's going to be 1/16. So in that little mini formula, and you see this, really you're going to take whatever your sine was and what the other piece was, you're simply going to square them. Alright, and after you square them, well, I'll let you figure that out. Pause the video, come back. Alright, so in your first problem, you were giving the cotangent of theta was equal to 1/4. Your job was to solve for the sine and for the secant of theta. So before you did all that, you had to find your x, your y, and your r values. You should have got x is equal to 1, y is equal to 4, and r is equal to the square root of 17. Plug in your values, and if necessary, rationalize any denominators. You should have gotten sine of theta is equal to 4 times the square root of 17, all divided by 17, and then that the secant of theta is just the square root of 17. Alright, for your next problem, we gave you tan of theta is equal to 60 over 11, and your job was to solve for sine square of theta plus the cosine square of theta. Alright, so before you could even have done any of this, you needed to understand that x was 11, y was 60, and r is equal to 61. Alright, so basically you know what your what tangent tells you, that x is 11, 60 is y. Basically use Pythagorean theorem to find out r, you get that. Alright, so what's happening in this part? Well, I gave you a hint earlier in the video that sine square theta is really this, sine of theta square. Alright? So this is the same thing with cosine. It's going to be cosine of theta square. Now, well, what was sine? Well, according to stuff and things, our sine is going to be y over r. So it's going to be 60 divided by 61 square. And now we need to find cosine of theta, which happens to be x, which is 11, divided by r. So it's going to be 11 divided by 61 square. So this is where we would have gotten to. We would have had sine of theta, which is 60 over 61, cosine of theta, which is 11 over 61, and what we're going to do now is basically use our handy dandy calculator to finish this all out. When we do, make sure, by the way, don't forget you do have the STO function on your calculator, basically your store function. That would have helped you drastically out with this problem because these give you some weird, funky decimals. So after you work all this out, you just get the simple answer of 1. So most of this video we've been able to do most of these things by hand. We're up to a part now that we can't. We need to start using the calculator to do some things. So that's what we're going to do now. We'll cut to the dot cam and let's go from there. Alright, so when we are working with degrees and trig functions, make sure your calculator is in what's called degree mode. I'm going to show you this with the TI-84. So step 1, I'm not going to write this down. You can just write it down for your own remembrance. Step 1, press the mode button. Okay, press mode. Step 2, scroll down until you see the word degree and hit enter. And step 3, hit second, quit, and all is well. Alright, so you have just set this up in mode. So just to kind of show it to you again, shouldn't be that hard. Hit mode, go down to degreedian, hit enter, and then just exit out and you're ready to go. Alright, so now that we're in mode, our mode is now in degree, excuse me, we can continue on. So, this is really simple, guys, alright? And I'm not going to spend a lot of time on this because you have a calculator, okay? So, it says find the value of the following trig functions. Round to 2 decimals as needed. You need to find tan of 60.6. Well, that's easy. Look at your calculator. You have some functions on it. You have sine, you have cosine, and you have tangent. Well, you're just going to hit tan 60.6 and you're done. Alright, and you find out that the answer is 1.77. Alright, so that's easy. Wow, that was hard. 1.77. The next one asks us to do cosine of 38.3. So we're going to find the cosine button, which is right here. Hit cosine, and then we're going to go 38.33. Press enter. We get 0.7, and we're going to 2 decimal places, so 78. And then finally, you hit the sine button, put 38 in, just like that, sine of 38, hit enter, and we're going to 2 decimal places again. We get 62. Alright, 0.62. Alright, so that's really all it is. Just kind of know where your sine functions and your cosine and tangent functions. Alright, now this is where things get a little bit more complicated. Alright, so this problem, let's read it. It says, find the value of the trig function. Round off results according to the angle and accuracy of trig function table. So what table am I talking about? Well, on your formula sheet, if you have a little table here, it says angle and accuracy of trig functions. And it gives us a little bit of information, and we'll explain that in just a moment. So we're going to be using this. Alright, here's the other thing you need to look at. This is cotangent. Look at your calculator. your calculator does not have a cotangent button. It has a sine, a cosine, and a tangent button. So we got a problem here. Well, that's where your formula sheets get ready to come back in. So check this out. I'm going to zoom in just a little bit for you so we can see just a little bit better. There we go. And I'll zoom back out. Look at what it says. I have cotangent. It says cotangent of theta is equal to 1 over tangent of theta. Alright, so what we can actually do is find out what the tangent of theta is and then divide that into 1 and we've got our cotangent. And the same principle applies with cosecant. If I find out whatever the sine of theta is, I can divide that into 1 to find the cosecant. And then just to find the secant, I can take the cosine of theta and divide that into 1. So let's show you how that really works. Zoom back out. Woo! Wow, you can really zoom in on this thing. How far? Uh-oh, my boy's crying in the background. Look at the point. That's kind of cool. All right, zoom out. There we go. All right, I'm going to pause the video and go check on my son. All right, so for this first one, it says that we need to do the cotangent of 36.93. Now, like I showed you all ago, we don't have a button on that on a calculator, but our equation sheet says that we can actually basically rewrite this to say 1 over the tangent of 36.93. That's really all we got to do. So let's do that in our calculator right now. We're going to say 1 divide by the tangent of 36.93. And what we do is we get 1.33 blah 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 blah. Now, our instructions told us to use that formula sheet in that chart. So let's look at what the chart does. It gives us some information. It says the measurement of angle to the nearest whole degree. We need to round our final trig function to 2 significant digits. If we're at the nearest tenth, we need to round it to 3 significant digits. Or if we're into the nearest hundredth, we need to round our answer to 4 significant digits. So since we had 36.93, that was to the nearest hundredth, we need to round our final answer to 4 significant digits. Well, we have 1, 2, 3. Well, what about that 0? Is this 0 a significant digit? Yes, it is, because it's between 2 sig figs, because 3 is a sig fig and 4 is a sig fig. So we're going to go 1, 2, 3, 4. Alright, so we're going to be rounding the 0. That 4 right here tells this 0 to stay the same, so and all these other ones get dropped, and so our final answer is going to become 1.330. And that's it. Okay? So the next one on our list is simply doing the secant. Alright? Well, according to our equation sheet, secant is really equal to 1 over the cosine of theta, and in this case it's going to be 28.1 degrees. So we're going to put that in our calculator. 1 divided by the cosine of 28.1. Enter. We get this number, 1.3 blah blah blah. Well, we need to look at it again. What did we start with? Well, this was to the nearest tenth. Degree was to the nearest tenth, and according to our chart, we need to round our answer, since it was to the nearest tenth, round our answer to 3 sig figs. So we're going to go 1, 2, 3. This 3 tells this 3 to stay the same, and so our final answer is going to become 1.13. That gives us 1, 2, 3 sig figs. Let's do this last one together. Cosecant. Well, according to the formula sheet, it says 1 divided by sine of theta. In this case, it's going to be 47 degrees. And when we work that out, we're going to say 1 divided by sine of 47. We get 1.36 blah blah blah. And since our original angle happened to be to the nearest whole, we're going to round our final answer to 2 significant digits. That's going to be 1, 2. That 6 tells that 3 to go up So our final answer in this case is going to be 1.4. Alright, so far we've been able to find the trig function, and we're able to find out what tan of theta is or whatever, and we're able to take the degree and find whatever tan of theta, tan of that degree, etc., and get some numbers. Alright, however, we can actually work backwards. Let's say we know what the ratio is, and our job, like on this one, it says that we have tan of theta is equal to 0.85. We already know what tan of theta is. The problem is we want to know what theta is. Basically, what is this degree? Well, this is pretty simple again, because we're going to be using a calculator. But what we're going to do is what we call inverse function. And the inverse function is basically the opposite of tangent. Think of it like this. Before we were building this number, now we're taking this number apart. Okay, think of it like that. So we're doing the opposite. And we could do this by hand, and people smarter than me that probably could do this. However, we have a calculator. So really, in order to find theta, all of this particular problem, I'm going to say that theta is really equal to the inverse tangent of 0.85. That's really all this is. Well, how do I do that? Oh boy, calculate time. So let's look at our calculator again. You have tangent, and just above tangent you see tan with a little -1 sign. It means inverse tangent. So really, this is all you get ready to do. Look how hard this is. Mind is about to be blown. Hit the second button, hit the tangent button, and now you put in 0.85. And now you're getting ready to find the inverse tangent of 0.85. You hit enter, and you have just solved your problem. And the answer it says to the nearest hundredth. So when we look at it, it's going to be 40.36 degrees. That's all that is. Alright, so look at the next one. This one's asking you to sign for theta. Well, I can rewrite this again. This doesn't, just letting you know, you don't have to rewrite this every time, because you should understand the concept here. So it's basically finding the inverse sine of 0.6522. We plug that in our calculator by going to second, right there, hit the sine button right here, so it says inverse sine, and we're going to go 0.6522, and when we do hit enter, we get 40.71 as our final answer. So 40.71 degrees. Same thing with cosine. We're going to do the inverse of cosine of 0.8562. Hit enter, and we got our answer again, which happens to be 31.11 degrees, rounded to the nearest hundredth. Okay, so that's pretty much simple stuff. When you're just find the inverse of it. All right, so we got more of the same here. I think you could probably do these on your own, but look, you're trying to find out what theta is using this information, but you're going to do something a little bit backwards. You're going to be using this chart again. So let's do the first one with you, and then I'm just going to shut my mouth and let you do the other two on your own. So we need to find out what theta is. So we know that we're going to hit second tangent to find the inverse of tangent of 0.569. And what we get is this long number, 29.63 blah blah blah. Now look at this chart. This is going to tell us how to round it according to this chart. So the trig function, if it has two significant digits, we need to round our answer to a whole. And if it has 3, we round it to the nearest tenth. And if it has 4, we round it to the nearest hundredth. So what did we start with? We have 1, 2, 3 numbers here in the fourth number, but let's ask ourselves, is this 0 really a sig fig? No, it's not, because it's at the beginning of any number. The only sig figs that we have are 1, 2, and 3. So since we have 3 sig figs, it tells us that we need to round our answer to the nearest tenth. And my boy's in the background again, but we're going to finish this out, and we're going to say that this is 29 since we're rounding to the nearest tenth, this is going to be 29.6 degrees. Try the other two on your own, and we'll come back and check your answers. Sorry to bug you guys. I know you're just about to work on these two problems. I did notice something that's wrong in your notes. Go ahead and correct that now. This right here should actually be 0.635. Apparently I got lazy when I was writing this, so this should be 0.365 and 4. There we go. Sorry about that. So go ahead and fix that in your notes. So this is cosine of theta is equal to 0.635 of n 4. All right. Now go ahead and try to work these problems out. So what you should have got for the first one was 70 degrees, and the reason why is since this was going to only had two significant digits, you had to round this to the nearest whole degree. This one had 1, 2, 3, 4 significant digits, so your answer will have to the nearest hundredth, so it's going to be 50.55. On your last page of notes, I've given you some problems where in this case we have to find secant of theta. Alright, and the next one's down is cosecant of theta, and what you should see on your page next is cotangent of theta. So as you already know, secant, cosecant, and cotangent are not in your calculator. They're not there. So we've got to do some finagling. We know that in order to solve this thing, we need to find the inverse of that. So we know that this theta is going to be the inverse of secant. Okay, so we understand that because it's the same process like we've done before. However, we don't have an inverse function of the secant. So this is where our calculator comes in. I mean, not our calculator, but our formula sheet. If you look at it, it's telling me that the inverse of secant is actually equal to the inverse of cosine, and then we're going to put 1 over x. So what's happening here? Check this out. What we're actually going to do is this. We're going to say that theta is equal to the inverse cosine of 1 divided by 1.43. That's what that formula is telling you right here, is that we were finding the inverse of secant, and since we were doing that, all we need to do is find the inverse cosine of whatever 1 over x is. So let's do that in our calculator. So we would hit the inverse cosine 1 divided by 1.43, and we get 45.62. So this time we're just going to round to the nearest tenth. 45.62 degrees. All right. So cosecant is very much the same problem, and so we know that we need to find the inverse function, or the inverse cosecant of 7.661, but we don't have a button for that. But according to our formula sheet, the inverse cosecant is equal to inverse sine over 1 over x. So we can re-say this as this. Theta is equal to the inverse sine of 1 divided by 7.661. Okay, well, let's do that in our calculator. We can say inverse sine of 1 divided by 7.661. And what we get is 7.5. And then we're going to round to the nearest tenth again, and we're going to say 7.5 degrees. Let's look at the last one, cotangent. Well, same principle. We know we need to go the inverse cotangent of 0.869. The problem is inverse cotangent doesn't exist on a calculator. So according to our formula sheet, though, we can rewrite it, this equation, and saying that theta is actually equal to the inverse tangent of 1 divided by 0.869. Plug that in our calculator. Inverse tangent of 1 divided by 0.869, and we get 49. And I'm going to round to the nearest tenth. In this case, it's just going to be 49.0 degrees. So And all of these things, I didn't realize I was off the camera. And so in all of these things, we have rounded to the 10th, and basically for secant, cosecant, and cotangent, we rewrite it using this formula sheet. We know that the inverse of secant is basically the inverse cosecant of 1 divided by x, and so forth, so on. You can read the formulas there. And that's really all this is. So what I want you to do is I want you to try the other side on your own. Okay? And pause the video, try them, come back and see how you did, and we'll go from there. The first one I got 86.0 degrees. You might have a slightly different variation. It just kind of depends on how you rounded, but you should get about 86 degrees on that. I rounded all of my stuff to the nearest tenth, by the way, so just be aware if yours doesn't match up with mine exact, it might be just because of how you rounded it. Alright, so the next one I have 7.0 degrees, and then for the last one I have 36.7 degrees. Basically, guys, that's pretty much it for this video. I'm not going to spend any more time on this. I think we've done pretty good on that. And the biggest thing I need you to understand is that this formula sheet is your best friend. If you don't have this formula sheet on test day, too bad, so sad for you. I would make sure I have it because you are going to need it. And as always, ask questions.